Welcome to this explainer. We hear the term agent thrown around constantly these days, right? But what actually makes an AI agent tick? How does it go from just generating text to actually solving problems autonomously? Well, today we're going to completely demystify the machinery under the hood. We'll give you a rock-solid mental model of exactly how they operate.
Here is our roadmap for today. We're going to cover building intelligence without structure, the three-component architecture, the agent loop in action, and finally, when to actually use AI agents. Let's jump right in.
Section 1. Building intelligence without structure. To really understand why agents are such a game changer, we first need to look at the painful reality of trying to build an intelligent assistant without this architecture.
Imagine someone asks an AI to just schedule a meeting with Sarah next week. It sounds super simple, right? But without an agent architecture, your system has to rigidly step through this totally exhausting sequence of tasks. First, it has to figure out who Sarah even is, then query both calendars, identify a free slot, send the invite, update the calendars, and finally tell the user it's done. If you're just hooking up a language model to some APIs, you literally have to write specific code for every single possible sequence and variation in that workflow.
And here's the crucial point. Handling complex, multi-step tasks with traditional automation forces you to write deeply, deeply fragile code. What if Sarah's busy? What if the user's calendar is entirely booked up? What if the email API throws some random error? You end up with thousands of lines of brittle if-then-else logic that inevitably shatters the very second someone asks something even slightly different. We desperately need a better way to handle complexity, one that uses flexible, intelligent behavior instead of rigid, hard-coded rules.
That brings us to Section 2, the three-component architecture, because we actually solve that brittle code nightmare using a brilliant, unified structural approach. Every single agent is built from three core components: the model, the tools, and the orchestration. I absolutely love the restaurant analogy for this. Think of the model as the cook. It's the intelligence that knows the recipes and makes the decisions. The tools? Those are the kitchen equipment, the stoves and knives that actually do the heavy lifting in the real world. And the orchestration is the process, taking the order, planning the meal, cooking it, and serving it. All three of these have to work perfectly together to serve a meal, or in our case, to achieve an autonomous goal.
Let's look a little closer at that first component, the model. Think of this as a centralized brain. It takes natural language and extracts the actual intent behind it, while expertly handling ambiguity. For example, if you say, "I need to be in Paris next week," the model recognizes that the destination is kind of vague. Are we talking about Paris, France, or Paris, Texas? It reasons through that ambiguity, asks for clarification, and constantly learns from feedback if its initial plan happens to fail.
But, as we know, even the smartest brain needs hands. And that's exactly why agents rely on tools to touch the external world, pull data, and execute operations. These usually fall into three buckets. You've got pre-built integrations, like a Google Flights API to search the web. You have custom functions, which is just your own existing application code, super handy when you need human approval before, say, making a purchase. And finally, information retrieval, which lets the agent dip into your company databases or customer histories to grab knowledge that goes way beyond its basic training data.
Let's jump to Section 3, the agent loop in action. We're going to see how this builds into an actual engine in motion by combining that brain and those hands into a continuous cycle.
The orchestration layer, that third critical piece of the puzzle, runs a constant, rhythmic cycle. The agent perceives the current situation, thinks about the logical next step, acts by leveraging a tool, and then checks to see if the overall goal is completed. If it's not done, the loop just starts right back up at the beginning. Perceive, think, act, check, over and over.
To watch this engine run in real time, let's track an agent iterating through its loops to handle a vague travel request. The user simply says, "Book me a flight to Paris next week." Let's see exactly how the architecture handles this without needing a single hard-coded if-then statement. This perfectly illustrates how the agent doesn't just blindly execute a script, it actively adapts. In iteration 1, it perceives the vague request, thinks about the missing info, and acts by asking the user, "France or Texas?" It checks its progress. "Nope, not done yet." The user replies, "France, I'm flexible on dates." Boom, iteration 2 kicks in. It perceives the new info, thinks, "Okay, I need to check availability," and acts by using the calendar tool to find open dates. Still not done, but we are making real autonomous progress here.
Round and round it goes, just chaining these tool calls together.
In iteration 3, it searches the flight tools using those newly found calendar dates and acts by presenting 3 flight options to the user. The moment the user picks one, iteration 4 begins. It perceives the choice, thinks it's ready to finalize, acts using the booking tool, and finally, the check phase registers that the core objective is fully achieved. Done. Your direct flight is booked. That right there is the magic of the agent loop.
Section 4. When to use AI agents. You now know exactly how this powerful machinery operates, but let's be real for a second. We need a reality check so we don't over-engineer simple problems just because agents are the hot new trend.
There are some really sharp binary contrasts here. An agent is a massive force multiplier for something like daily business intelligence. Imagine an agent that wakes up at 8 a.m., pulls metrics from 3 different sales systems, analyzes historical trends, and emails executives a custom brief on anomalies. I mean, that is incredible. But on the flip side, agents make 0 sense for a simple "what's today's weather" prompt. Putting an agent loop on a single, simple API call is literally like using a high-latency helicopter just across the street. It adds time and cost where traditional automation will be way, way faster.
So, to avoid building an overly complex agent for something like a basic FAQ bot, you should strictly use this decision matrix. Ask yourself, does the task require multiple steps that depend on each other? Does it need to adapt based on what it discovers? Does it require complex reasoning? And does it actually need to take action in external systems? If you are answering yes to most of these, congratulations, you've got an agent-shaped problem that truly requires autonomous reasoning.
Which leads us to my absolute favorite mental model for all of this. An LLM by itself is just a consultant. It gives you advice, but it doesn't implement a thing. An LLM connected to functions is an assistant. It can use tools, sure, but only when you explicitly hold its hand and tell it exactly what to do. But an agent? Ultimately, combining the model, the tools, and the orchestration promotes your AI to an autonomous, trusted employee. You just hand them the end goal, and they figure out the process.
As we wrap up this explainer, I want you to evaluate your own tasks with this brand new architectural mental model. Look at your day-to-day operations. What complex, multi-step processes are you currently babysitting with brittle code or manual labor? Ask yourself what workflows you can finally hand over to an autonomous AI agent now that you know exactly how to build one. Thanks for joining me on this deep dive, and I challenge you to start applying this structure to your next big project.